Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today we will go into Chapter 6, Electrochemistry for AS. So we'll make use of oxidation number to balance a chemical equation. So these are the steps that we could use to balance a chemical equation making use of oxidation number. So first of all, we need to identify the atom which change in oxidation number. So normally we will focus on element which have variable oxygen state. So normally we have transition element. So if they are non-metal, we'll have halogen, where we have chlorine, bromine, or iodine from group 17. We have also nitrogen, phosphorus, and sulfur. So these are the elements that they have variable oxidation number. So normally we will focus on them in getting the atoms which change in oxidation number. So then we got to deduce the oxidation number changes to balance the oxidation number. So after balancing oxidation number, we will need to balance charge for an ionic equation where we have ions involved in the equation. If not, we could actually skip this step and move on to the last step to balance the atoms. So let's use example 1 in making use of oxidation number to balance this equation. So first of all, we have to identify the atoms which change in oxidation number. So where we have copper in copper oxide, to have +2 as the oxidation number, and the product of it, which is copper, with 0 oxidation number. So the change in oxidation number here for copper, it's -2. So next, we have nitrogen. So nitrogen in ammonia, it's with -3 as the oxidation number. So the change of it, it will become N2 to have 0 oxidation number. So it undergo oxidation, changing from -3 to 0. So the change in oxidation number here, it's +3. So here, we could actually see the oxidation number, it's not balanced. So we have +2 and -3, which is the net here, it is -1 for the left hand side. So then for the right hand side, we'll have both 0. So this we could see the oxidation number, it's actually not balanced. We have -1 on the left and we have 0 on the right. So in order to balance it, we could actually make use of a factor. So we can have ×3 for copper to have -6. And then the factor to use for nitrogen is actually 2. So we multiply 2 for nitrogen. So after putting in the factor, we could actually see the oxidation number is balanced. So which is the third step here, where we balance the oxidation number, making use of a factor. So we could actually see the oxidation number is balanced. So we see here 3 times +2 is +6. So 2 multiplied -3, it is -6. So +6 and -6 overall here, we have 0 oxidation number. And it is actually the same as what we have on the right hand side. It is 0 as well. So after balancing the oxidation number, we will skip the fourth step, balancing the charges because they are neutral compound. So we can actually move into the last step, which is balancing the atoms. So we have 3 copper on the left hand side and we have only 1 copper on the right hand side. So we can put 3 here to balance the copper atom. And we have 2 nitrogen on the left. So just nice, we have N2 where we have 2 nitrogen atom on the right hand side. So next to go, we have 6 hydrogen on the left hand side and we only have 2 on the right hand side. So we could actually multiply H2O to 3. So we will have 6 hydrogen atom on the right, and just nice, it could actually balance off the oxygen atom with 3 oxygen atom on the right and 3 oxygen atom on the left. So now all atoms are balanced and we will have a balanced equation. Okay, next, let's see example 2. Example 2 is an ionic equation with all ions and charges in the equation. So we can actually make use of this to show how to balance the charges in an equation. So first of all, we need to identify the atom change in oxidation number where we have manganese. So we have +2 for Mn2 plus, and in MnO4 minus, the oxidation number for Mn, manganese, is actually +7. So the change in oxidation number here is actually -5. So next to go, iron 2 plus is the one that undergo oxidation. So the oxidation number changes from +2 to +3. So change in oxidation number here, it's +1. So the oxidation number is not balanced for the left and right. We have +7, +2 here. We have +4 oxidation number on the left, but we have +5 oxidation number for the right hand side. So they are not balanced. So in order to balance it, we could actually multiply 1 and 5. So let's multiply both ions with the factor of 5. So you could actually see we have +7, +10. So total of it, we have +17 oxidation number on the left. And for the right hand side, we have 5 times +3. We have +15 plus +2 here. Total, we have +17 as well. So this we could actually see the oxidation number on the left and right, they are balanced, where both sides are with +17 as the oxidation number. So done with balancing the oxidation number, so next to move, we need to balance the charges. So let's see what's the charges that we have on the left hand side of the equation. So we have -1 for MnO4 minus. So then we have +2 for Fe ion here, and with 5 moles of +2, we will have +10 for the charge of 5 Fe2 plus ions. And next to go, we have +1 for H plus. So there will be +1. So the total charge for the left hand side here is actually +10. So let's see for the right hand side of the arrow. So we have +2 for Mn2+. And next, we have +3 for the ion, and there's 5 moles of it, so the total charge of them is +15. And next, we have 0 charge from H2O molecule. So the total charges for the right hand side is actually +17. So here we could actually see the charges for the left and right are not balanced. So in order to balance off the charge, normally we will focus on ions, which is with only one atom, like H+ or Mn2+. So then here we have more positive on the right than the left. So therefore here we need to balance off the positive charge on the left hand side. So we could actually focus on H+ ion. So where here in this case we got to multiply 8. So we have +8 for H+ ions. So in total, +8 minus 1 and +10. So we have +17 for the new charges for the left hand side. So this is how we balance off the charges for the left and right hand side. So after balancing the charges, we will need to move to the last step, which is to balance the atoms. So we will have 1 Mn and 1 Nn on the both side, and the ion are balanced as well. So where we have 5 iron and 5 Fe on the right. So next to go for hydrogen atom. So for the hydrogen atom to go, we have 8 hydrogen atom on the left and we have only 2 on the right. So H2O got to multiply by 4 to have 8 hydrogen atom. So just nice to balance off the oxygen atom, which is 4 on the right and 4 on the left. So now this equation is balanced.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.